We're ready for exercise 3.2, and we're going to follow the same steps that we've been taking all along, where we find the derivative, find the critical values, find the endpoints, and then plug them into our function to see what our solutions are. So what am I going to do first? First, I'm going to find critical points. I'll just abbreviate. Critical points, critical numbers, critical values, those all mean the same thing to me. I use those points like interchangeably, although it's probably not fair. So find the critical points. How do we find the critical points? Well, the first thing we should do is take the derivative. So you take the derivative, and we get 4x cubed minus 10x. You all are really good at this. Then, once we have this, we need to ask ourselves two questions. Where does the derivative not exist? This derivative always exists. So I'm just going to write myself a little note over here. Y prime always exists. So that means I don't have to worry about the does not exist critical points. How do I know it always exists? Well, look at this function. We're never dividing by 0. We're never taking square roots or logs or anything like that. This is just a nice function. It's always exists. Okay. Usually that's going to be the case. Usually you look at this equation, it will always exist. But you need to always ask yourself that question. Are there points where the derivative doesn't exist? Because the answer is yes, then you need to kind of change the way you work on things. Okay, so y prime always exists. So what that means is I'm just going to take my function and figure out where it's 0. So I'm going to take my 4x cubed minus 10x and put equal to 0 here, and then start solving it. What I'm going to do is I'm just going to factor out an x. Now I'll have x times 4x squared minus 10 equals 0. This seemed like the easiest thing for me to do. And then you'll see we have two solutions. One is x equals 0, and the other solution is 4x squared minus 10 equals 0. This one we get 4x squared equal to 10. X squared equals to 10 fourths, which is 2.5. And so x is plus or minus the square root of 2.5. Okay, so that seems reasonable. So what we got, right, so what we had here was 3 critical points. So critical point number 1 came from x equals 0, and critical points number 2 or 3 came from the plus or minus that side. Right over there. Okay, now all I need to do is go through and plug. Okay, so there's my critical points. Sorry, the next thing I need to do is my endpoints. And those are quite easy. My endpoints are just, they're the endpoints from the problem. And the problem is x equals 2 and x equals negative 2. So now the only thing left is for me to plug everything into my original equation and see what I get for my answers. So the final step is plug in. Plug into f of x, our original equation. So we plug into that x to the 4th minus 5x squared equation. And so we get f of 0, and that is 0 to the 4th minus 5 times 0 squared, and that is just 0. And then we've got f of the square root of 2.5, and that is the square root of 2.5 to the 4th minus 5 times 2.5 squared. I have a feeling this is not going to be friendly, so let me just plug it in here and see what I get. I've got, it's not that bad, negative 6.25. Oh yeah, because notice these are both even powers, so your square roots, so your square roots disappear. So negative 6.25 is what I got for that one. And when I do negative the square root of 2.5, notice it's going to be the same thing because I've got negative square root of 2.5 to the 4th minus 5 times negative square root of 2.5 squared negative 6.25. Notice it's the exact same because these numbers are the same and both of my negatives had even power, so this negative got squared and this negative got raised to the 4th, so the negatives all disappear. Okay. Now the last thing I need to do is look at my endpoints. And so f of 2 is 2 to the 4th minus 5 times 2 squared. And so what is that? 2, 4, 8, 16 minus 4 minus 20. So it looks like negative 4 is what I get for that answer, I think. Negative 4. And now when I do negative 2, I get the exact same thing. And I get negative 4. So now the last thing that I have to do is I have to go through this problem and I have to figure out what is my what are my maximum and minimum values, so I can state those for my teacher, and so my teacher is happy. In this case, it's me. Okay, so the last thing I do is write my answer. And as I look through all these, I go, what is the biggest? It looks like 0 is the biggest. And it looks like this negative 6.25 is the smallest. So I'm just going to get myself in a habit of always writing these out in a really clear fashion, where I say the max is 0 at x equals 0, and the min is negative 6.25 at x equals plus or minus the square root of 2.5. Now, notice it's actually okay to have the minimum occur in more than one place. And here I've got my graph drawn for you so you can look at it, and you can see that our picture, if we look at it, I just messed it all up. Let me come back here. Negative 2 to 2. So if you look, what you'll see is that we have a minimum, but we actually have that minimum occurring twice. So it's perfectly fine to have 2 minimum values, 1 minimum value there and 1 minimum value there. So the minimum value is however high or low it is on the graph, but the x value is where it occurs. So it occurs twice at 2 different x values. All right. Hopefully that worked out well. Try exercise 3.3 where we throw some fractions in at you and a quotient rule. And good luck, and I'll see you in just a minute.